The soil air has the following effect on agriculture. Oxygen in soil air promotes easy germination of seed and is also necessary for the growth and development of plants. Then soil organisms require air for respiration. Then the third effect it has is that soil air is needed in soil reaction, particularly carbon and nitrogen cycle. And also the last excess carbon dioxide in soil, when combined with water, can cause acidity, and which is the weathering of the rock, or once the carbon dioxide is too much, it will cause the formation of acid. And once we have acid soil, the organisms in the soil, it will inhibit the activity of the organisms, such like the termites and the other organisms present in the soil. Now we have the soil microbes. The soil microbes, such as bacteria, fungi, virus, and helps in converting complex minerals and nutrients in the soil to simpler form that can be used up by the plants. Such bacteria are nitrosomonas, which helps to change ammonia to diazonitrate 3. Then we have the nitrobacter type of bacteria that helps in converting diazonitrate 3 to triazonitrate 5 in the soil. Hence, they help in fixing nutrients in the soil. Then the last one is macroorganisms. That is, we've been talking about the components of soil, that is the composition, what makes up soil. Here we are having macroorganisms. Macroorganisms refers to larger organisms such as nematodes, termites, ants, millipedes, earthworm, rodents, etc. and so on. Macroorganisms have the following effects on agriculture. They help in improving the aeration of the soil, that is the burrowing activity. The burrowing activity tends to increase the pore space in the soil. They help in improving soil structure. They also help to decompose organic matter in the soil to form humus. And they help in improving the soil water infiltration or drainage through their burrowing activities. That is, once there is the pore space is being increased, there will be infiltration or draining, that is easy movement of water within the soil. Then the last one is through the burrowing activities, they leave holes for crop root penetration. That is, the crop root will find pore space through which they can easily penetrate. Now our next subtopic is soil pH. Soil pH is a measure of the acidity or alkalinity of the soil. It can also be defined as a measure of hydrogen ion in the soil. A higher hydrogen ion concentration indicates soil acidity, while a lower concentration of hydrogen ion indicates soil alkalinity. A pH scale graduated from 1 to 14 has been developed to measure the degree of acidity or alkalinity of the soil. Soil pH below 7 is said to be acidic, while soil pH above 7 is said to be alkaline in nature, while a pH of 7 is said to be neutral. Soil pH depends on the mineral of the original soil material or rock material, and on the extent of leaching which has taken place on the soil. Leaching makes the soil more acidic in nature, thereby inhibiting the activities of soil microorganisms. The addition of limestone, that is calcium triazocarbonate 5, or slaked lime, that is calcium hydroxide, or chalk, that is, if we had limestone, slaked lime, just as we are seeing here, to soil, it helps in correcting or reducing the acidity of the soil, thus enabling soil microorganisms to function properly. And then, once they function properly, the air helps in fixing and the fertility, fixing nutrients in the soil, thereby increasing the fertility of the soil. This process of reducing soil acidity is known as liming. Then our next subtopic will be soil texture. Soil texture can be defined as the characteristic feel and physical handling properties of the soil. These characteristics depend on the soil type. It's also the proportion of the different size particles that makes up a soil sample. The feel of the soil gives some indication of the percentages of sand, silt, and clay in the soil. Soil texture can be determined by the following ways. Number one is feeling, that is, by rubbing the sample between the fingers to show whether it is coarse, fine, or by sedimentation and sieve method. When you say sedimentation, that means we pour our sand inside water, we set it properly, and then allow it to settle. By the time it settles, we now see that there will be different layers of soil. With that, we determine the texture of the soil, and we can also use sieve method. This is a collection of sieves with different openings of the mesh of the sieve. The smallest mesh is at the top, while the smallest size of mesh is at the top, while the biggest one is at the bottom. With this method of texture determination, there are three main types of soil, which are namely sand, clay, and loam. The finest particle will be at the top, which is clay, while our loam will be at the middle, and then our sand will be at the bottom, which has the highest size of particle. Then we have the molding. If we mix a sample of soil with little water and try to mold the mixture, if the mixture is sticky and you can mold something out of the sample, that is the mixture, then it shows that clay is present. But if the mixture is not sticky and a ribbon or a cast cannot be made, that is, you can't mold anything from that mixture, then it shows that sand is present. Now we'll now be looking at soil structure. Soil structure refers to the ways in which the different particles of the soil are packed or arranged to form crumbs or aggregates. The formation of the soil particles into definite structural pattern is affected by the cementing or binding agents like the colloidal clay or the colloidal humus or the hydrated oxides, just like the iron 3 oxide. Importance of soil structure. A good soil structure facilitates the suitable. A good soil structure facilitates suitable seedbed formation. Also, a good soil structure supports optimum aeration. That is, if the soil structure is good, then it will support optimum aeration. A good soil structure also permits optimum water holding capacity during plant growth and also prevents water logging. That is, it holds optimum water within it and allows the excesses to be drained off without causing water logging. Then a good soil structure promotes the activity of soil organisms. A good soil structure also prevents soil erosion, that is, the soil particles are being held together properly, and then a good soil structure enhances the growth of crops. Now we'll now be looking at some revision questions. Now, the first question that we are having here says that a soil with low pH value can be improved by the addition of A. Ammonium sulfate, B. Calcium carbonate, C. Sodium chloride, D. Sodium nitrate, E. Magnesium sulfate. Our answer is B, which is calcium carbonate. If you add calcium carbonate to a soil with low pH, that is, a soil having a pH below 7, is being categorized as low pH, and such soil is being referred to as acidic soil. If we had limestone or calcium carbonate, like our limestone is the same thing as calcium carbonate, if we add it to it, it will improve the soil. Then the next question is our question number 2. The major climatic factors that influence agricultural activities in the tropics include the following, except A. Rainfall, B. Temperature, C. Sunlight, D. Pressure, E. Wind. The answer is D. Pressure. Others affect, influence, the question says the major climatic factors that influence agricultural activities. Rainfall will influence, temperature will influence agricultural activities, sunlight is necessary for photosynthesis, wind also aid pollination, that is, and we need air for photosynthesis also to take place, because carbon dioxide is required. And but pressure, how does pressure influence agricultural activity? No, it's okay. The question says that the major climatic factor that influence agricultural activities in the tropics include the following, except pressure, which is D. Then number 3, the most important limiting factor in crop production is let's just remove that limiting factor in crop production is what? Is A. Rainfall, B. Temperature, C. Atmospheric pressure, D. Light, E. Humidity. They say the most important limiting factor in crop production is what? Is rainfall. If there's no water, there's no how the plant is going to grow or grow optimally or produce optimum production. We need water. Plants need water for optimal production. Then the number 4 question says the type of crops planted and the livestock raised in any given area depends primarily on A. the type of climate, B. physical factors, C. biotic factors, D. socio-economic factors, E. edaphic factors. The answer is A. the type of climate. That is, the climate of an area will determine the type of crops that are planted and the livestock being raised. Then our 5th question says that which of the following is not a biotic factor affecting agricultural production? A. predators, B. soil, C. parasites, D. pests, E. disease. The answer is B. B is not a biotic factor affecting agricultural. Predators is a biotic factor, parasite is a biotic factor, pest is a biotic factor, and disease also is a biotic factor affecting agricultural production. Then the 6th question says that land is considered to be an essential factor in agricultural production because it is most abundant, it is important for development. C. crops, fisheries, and livestock production are practiced on land. D. it cannot be increased in quantity. E. crop production is usually done on land. The answer is C. crop, fisheries, and livestock production are practiced on land. Then our next question, which is question number 7. During the process of soil formation, the cracks or crevices that are first noticed on the rocks are normally caused by what? A. ice, B. man, C. wind, D. temperature, and E. solution. The answer is D. The first crack is being caused by temperature, that is the changes in temperature. Then the next question says that rocks formed from already existing rocks as a result of sudden changes, That is, sudden changes in form and structure are known as. That's sudden changes means the metamorphosis of one form of rock to the other. The first option says igneous rocks, B. Sedimentary, C. Sedentary rocks, D. Metamorphic rock, E. Calcareous rock. The answer is D. Metamorphic rock. Metamorphic rock are formed from the already existing rock as a result of existing changes in form and structure. Then, question number 9. Which of the following is not a component of soil? We have here A. Air, B. Water, C. Organic matter, D. Microorganism, E. Texture. Now, if you look at the area of option that we are having, E is the correct answer because E, texture, is not a component of soil. It's a characteristic of soil. Then our next question is question number 10. Loam soil is best described as soil which contains only organic matter, has little or no organic matter, C. absorbs a large quantity of heat, D. harbors different types of microorganisms, E. contains sand and clay in the right proportion. The answer is E. Contains sand. Loam contains sand and clay in the right proportion. Question number 11. In which of the following ways are metamorphic rocks formed? A. By physical disintegration of igneous rocks. B. By alternative layering of particles of sedimentary and igneous rock. C. By the combination of igneous and sedimentary rock. D. Through biological changes of original rocks. E. Through chemical changes caused by heat and pressure. E is the correct answer. Through chemical, metamorphic rock are formed through chemical changes caused by heat and pressure. And with that, we come to the end of our scene 2.